Hi, my name is Jeff Davies, and this is Lab 8 of the OCI test drive. To get started, you'll want to go to my website, jeffdavies.org, where I've got some simple links for you. And we're going to open up the OCI test drive Labs100 as usual. In the README file, click on the L100 lab link, and then click on Load Balancer to open up that lab. The OCI load balancing service provides automated traffic distribution from one entry point to multiple servers reachable from your virtual cloud network. The server offers a load balancer with your choice of public or private IP addresses and provisioned bandwidth. Let's go ahead and get started. As you can see here, this is an example of the load balancer and essentially what we're going to build today in this lab. So there is a load balancer on a public IP address. It has a built-in failover, and it has a backend set. The backend set is going to be two different compute instances that are both running the same software. And so when the load balancer gets an HTTP request, it will load balance across those two compute instances. So as usual, we need to log into the Oracle Cloud using your tenancy, and we'll get going from there. So for this lab, we're going to start by creating a virtual cloud network just for the load balancing. So we'll go to Networking, Virtual Cloud Networks, and we're going to create a VCN. We're going to call the VCN Web. It's going to be created in our demo compartment. We're going to give it a CIDR block of 10.0.0.0/16. And since we've used this CIDR block in a previous VCN, there won't be any conflict. But by reusing the exact same CIDR block, we've made a design decision that this virtual cloud network will never be able to communicate with the other virtual cloud network that we've created. But that's okay for the purposes of this demo. Okay, we don't need any tags, so let's just press Create VCN. And it virtually instantly creates our virtual cloud network for us. So now we have to go in and edit our security lists. We're going to create a new security list on top of the default one, and our new security list is going to be named LB-security, the LB for load balancer, of course, also in the demo compartment. And just hit create security list. And then we're going to create an additional security list called web security list. And here we're going to click on additional ingress rule. And it's going to be for a CIDR block. It's going to be from any source for TCP, and the port range is going to be 22. And we're going to create an egress rule for same CIDR block 0. Our IP protocol for this is going to be all protocols. And we'll create that security list. Now we want to allow traffic from the internet to be able to connect to our load balancer. So for that, we're going to create an internet gateway. So we click on Internet Gateways, create Internet Gateway. We'll name it Internet Gateway, also in the demo compartment. No need for tags. So now we have to modify the route tables. And we're going to create a new route table. We're going to name it route table, just to keep things simple. Then click on the route table, and we're going to add a route rule to it. The route rule is going to be for the internet gateway. We're saying all destinations for the internet gateway. Then select your internet gateway as the target and click the Add Route Rules. Okay, so let's go back to the VCN web. We're going to create a subnet now. So under Resources, click Subnets. Create subnet. Name here is going to be LB subnet. It's going to be regional also. CIDR block 10.0.1.0/24. We're going to select route table. We want to have public access. So public subnet is selected. We can ignore the DNS label. DHCP options are going to be the default for our VCN. And the security list is going to be our load balancer security list. We say create subnet. Now we're going to create another subnet for the web servers. So click create subnet. Name for this one naturally is going to be web subnet. It's also going to be regional. It's going to have a different CIDR block, 10.0.2.0, 10.0.2.0/24. The route table is going to be route table. We also want it to be public subnet access. DHCP options are going to be the default. And security list is web security list. Click create subnet. Okay, so our load balancer is defined, but it needs some web servers to connect to. So to do that, we're now going to move into practice 2 in this lab, which is creating 2 web servers. So we're going to scroll down here, practice 2, creating 2 web servers. We're going to create 2 compute instances. We're going to have them web server 1 and web server 2. They're going to be in the availability domain 3. They're going to have the micro shape. We're going to use the subnet for the web. We're going to assign a public IP address, and we're going to enter our SSH key, and then we're going to create them. So you see down here we have web server 2 and web server 1. So let's go ahead and get that done. So we go to compute instances. Web server -1. Availability domain. Image is fine. The shape, we're going to change that to something really small. The standard E2 micro is just very small OCPU, very small memory requirement, but our web server is not going to be taking a lot of traffic, and we're only in a trial environment, so there's no point in using up all those resources. So we select that shape. We want to make sure our web subnet regional is selected. We want to choose our SSH keys, which are going to be located usually in your SSH folder. And press create for the first one. Okay, so let's go back to instances while this one is being created. Let's create another instance, and let's call this one Web Server 2. Also in availability domain 3, we're going to change the shape again to another very small one. In the demo compartment, using the correct subnet, public IP address, assign the same SSH key, and we'll create this one. So let's go back to view our instances. One is still being provisioned. Let's get our terminal ready to go, because we're going to end up SSHing into each one of these web servers to further configure them. We're simply waiting for the provisioning status to change to running, and then we'll be able to SSH into each one of these. Okay, so the first server is ready to be configured. We can copy that IP address. We're going to change into our terminal. We're going to SSH to OPC at that IP address. We want to continue. Okay, now that we're into the first one, we have a number of commands that we have to execute here, and those commands are listed down here. So you can see we're going to install Apache first. And then while that's going, we're going to start Apache. Once this is done installing. Okay, very good. We're going to start it. We're going to enable system control so it auto reboots, or it comes up when the machine is rebooted. Run a quick test. Looks okay. Now we have to create a firewall to allow access to port 80. We're adding a rule for HTTP, and then we force the firewall to reload. Now we're going to create an index file for web server 1. And all this is just going to be a very simple file so we know the web server is alive and running. So as you see, it's just going to be a flat text file. It's going to be an HTML format, but really it's just flat text going in. It says this is my web server 1 running. Okay, so that one's good. And then we're going to do the exact same thing. We're going to exit out of here, and we're going to connect to web server 2. So let's go back to our instances. We see web server 2 is running. We copy that IP address, and we repeat the entire process. Now for the second one, I'm going to go back to the lab. You want to copy this second one. All it does is it changes the text to say web server 2 instead of web server 1, but this allows us to see that the load balancer is working. Okay, so if that seems a little onerous to you to have to create individual instances, you're right. If you were doing this at scale and you needed to create anything more than just a couple of servers that are exactly the same, if you had to create 5 or 10 or 15, 20, hundreds, what you would normally do is you would create the first server and configure it the way you wanted it configured. And then you would create an image. Now, creating an image is outside the scope of this particular lab, but I just wanted to plant that seed for you. So later on, if you're interested in doing this at scale, you'll know to create an image. And then when you create instances, you're just going to apply that image to the instance, and it will come pre-configured as a result. So now we're going to go on to creating and testing the load balancer itself. Earlier, we created the network rules for the load balancer, but now we're going to create the load balancer itself, and we're going to assign these 2 web servers as the backend servers or the backend set for that load balancer. We're going to create a load balancer called LB Web Servers. We go to networking, load balancers, create a load balancer. LB Web Servers. We want it to be public because we want it to be able to accept connections from the internet. Technically, our compute instances didn't need to be public per se if you had them configured with an image. Since we didn't use an image, we needed SSH to connect to them from the internet, so they had to have a public IP address. But depending on how you configure yours, you can do your actual compute instances without a public IP address, and only public IP address is going to have to be the load balancer as an option. Okay, so we've got our load balancer. We want it to be public. We want a small instance because we're not driving a lot of traffic through our trial accounts. Our VCN is going to be our VCN web, not the other VCN. And we want our LB subnet regional in here. Then we're going to go next. Verify that the protocol for HTTP is set to port 80. The rest of these defaults should be just fine, so we'll press next. Okay. Now it's going to ask us to create a listener, so let's make our listener web. We want it to listen on HTTP. You can enable HTTPS also, but we're just going to stick with HTTP for now. We'll skip the maximum timeout in seconds. And we create the load balancer. So now that we have the load balancer, we need to update our load balancer security list to allow traffic to the listener. I'm going to go to networking. For the VCN web. And we go to our security list, and we're going to update our LB security list to allow internet traffic to the listener. So we're going to create a new ingress rule to allow incoming traffic. So any source using TCP/IP accessing port 80 only Now, we also need to create an egress rule. So we have to allow response traffic out. So we're going to add an egress rule. Destination is anyone. IP protocol is just going to be all protocols. Now we need to update the web security lists. So we go back to security lists. We see web security list. We're going to update this. And what we're going to do here is we're going to allow traffic from the load balancer to the web servers. So we've clicked on our web security list. We're going to add an ingress rule. Our CIDR block is 10.0.1.0/24. This is over TCP/IP, only for port 80. We're going to add that ingress rule. Let's take a look at our load balancer, and you'll see that it says the overall health is unknown and the backend health sets are unknown. So once that load balancer is created, we need to go to backend sets. It's created a default backend set for us, but there's no backends. So click on backends, and we're going to add some backends. We're going to add web server 1 and web server 2. So we're going to apply our load balancer security list and the web security list. We're going to hit add. Okay, so this may take a few minutes to go configure the load balancer. Let's say close. You'll notice it doesn't show up right away, and that's because there's a back-end process going on. We see the first backend come up, and the second backend comes up. So now we are ready to test. And I'm going to open up a new tab for this. And we're going to go back to our virtual cloud network. We're going to look up our load balancer. Because we made our load balancer public, it has a public IP address. We open up a web browser and we point it to the IP address of the load balancer. And you see the first one we hit is web server 2. We hit it again, and now we hit web server 1, 2, and there you go. You can see the load balancer is up and running. So that's it for this lab, and I will see you in the next lab. Thank you very much for watching.